Good evening, ladies and gentlemen. It's a pleasure to be here this afternoon. Our project is the effects of microgravity on the turbidity of a non-Newtonian fluid mixture of cornstarch and water. My name is Tevin Glover. This is Parker Matthews. Unfortunately, Mr. McQueen couldn't be here with us today. Our group's research question is, how does microgravity affect the turbidity of a non-Newtonian mixture of cornstarch and water? A non-Newtonian fluid is firm when you hit it, hard or fast, but when you operate it in slow motion, it acts like a liquid. This makes it difficult to classify non-Newtonian fluids as solids or as fluids. Turbidity is the measure of the amount of light that can pass through a water sample. The more turbid a mixture is, the less light is able to pass through. Our group wants to see how microgravity will affect the movement of starch particles in a solution. In normal gravity, particles in solutions move from higher to lower concentrations until they are in equilibrium. This matters because plants store starch in their roots, so our experiment could be applied to help the growth of plants in microgravity.
The original experimental design, the materials needed for this experiment were an FME3, 2 clamps, 6.9 milliliters of Argo brand cornstarch, and 2.3 milliliters of distilled water. These amounts came from proportions given to make larger batches of this mixture, as well as some adjustments when experimented with placing the mixture in a sample FME. Our original procedure, we are requesting that the astronaut technician unclamp on the first day of arrival and shake vigorously for 90 seconds. The non-Newtonian fluid will sit until it is undocked before 2 days. We request that the astronaut technician reclamp the tube in the original location. Once returned to Earth, each sample will be transferred to a test tube where the turbidity will be tested. The ground truth experiment will be the exact same experiment that will be tested in space. It will be the same experiment, of course. Nothing would be changed. Our updated procedure, based on recommendations from the Step 2 Review Board, we have modified our experiment to the FME3 enclosure in order to have 3 samples to compare turbidity instead of 2. Volumes of materials were adjusted to mimic the concentrations of starch solutions found in plant roots. Analyzing the results. Once we get the results back from the space station, we will analyze the ones from the ground truth experiment and the ones from in space. We will run it through a turbidity sensor and see how turbid the solutions are.
We would like to thank the Center for the Advancement of Science in Space, which is a SSEP national partner. We would like to thank W.J. Keenan High School Cluster, the Challenger Learning Center, and Dr. Anthony Stewart of Allen University.